We start with a speaker, Dr. Megan Williams from the Geological Survey, and she will talk about a Geological Survey project. So Megan completed her PhD at the Adelaide University in 2019, and she has a background in metamorphic petrology and mineral chemistry. So currently Megan is a senior geologist at the Geological Survey, where she is leading a team that manages the state's stratigraphy and that develops a digital explanatory notes system. So please welcome Megan.
So I'd like to start today by acknowledging that while we're meeting today on Kaurna land, the work that I'm speaking about covers the Gogatha, Wirangu, Bangala, Ngawu, Nukunu, Naranga and Arabana lands, and will in time extend to the lands of all the First Peoples of South Australia. We know people like map data. The statewide 250k map sheets are still one of the most highly downloaded products from SARIG, which indicates a fundamental requirement for broad-scale information about geology. We have a lot of data from the GSSA that can help explorers and researchers have a better understanding of the state's geology, but they're often locked in drill hole logs, in reports, places like that. Our existing explanatory notes for the 250k and special edition map sheets have a wealth of information, but were published over quite a long period of time and are not necessarily consistent between adjacent map sheets, let alone across the whole state. The most comprehensive information source we have is Bulletin 54, the Green Book, but this was published nearly 30 years ago. Needless to say, we've come a long way in our understanding of geology since the early 90s, assisted by high-resolution geophysical data, a huge number of new drill holes, and widespread geochronology and geochemical data. But since this data is not well linked to our maps, it can be challenging to find what you're after and to know that you have everything that's available for an area. So every time someone picks up new ground or starts a new project, they have to start from scratch, pulling all of this information together. We're aiming to make this process easier by pulling together the most up-to-date information about the state's geology into one place, the new digital explanatory notes. These will be based around stratigraphy, like our map data, but will also include some more generalised descriptions of the state's geological history and provinces. They'll be linked to maps, so with a simple one or two click through, you'll be able to go from our maps on SARIG to detailed generalised descriptions of what that map unit is, what the rocks look like. They'll also be linked together, so it'll be easy to find related stratigraphy, tectonic events, or geological overviews. And there'll be keyword search functions to find specific terms of interest. So the digital explanatory notes sits within the South Australian Discovery Mapping project. And through this project, as Rowan mentioned this morning, we have funding to fundamentally redesign how we capture and deliver our geological data. The project includes compiling and reinterpreting our map data, adding rich attribution along the way. We have the digital explanatory notes, which I'm talking about today, and we'll be building new back-end systems which utilise modern technology to help deliver high-quality integrated system linking together all of the geological information that we have. All of this data will be delivered out through SARIG and through new web services. This project has only been going for a year, so this is a pretty preliminary progress report, and we'll be releasing data periodically through our publications and catalogue before the new system is deployed in 2024. So you can check out the project website for progress updates as we go. So what's involved in putting together the digital explanatory notes? We review the data that's available on each of the mapped stratigraphic units, of which there are over 2,000 in South Australia, so there's quite a lot of different areas to look at. We synthesise all of that information into a coherent statewide description and then identify any stratigraphy that needs updating. The result will be a few-page summary of the key information about the rocks, including things like the lithology, alteration and mineralisation, age, geophysical and geochemical characteristics, and there'll be a series of key references that will help assist with further inquiry. I'd now like to share an example of what the power is of sorting out our stratigraphy. The Hiltaba Suite is something that we think of as a pretty well-known and understood group of rocks. And there's certainly lots of literature out there on the Hiltaba Suite. But despite all of the work and the significance of the suite for ICG and copper mineralisation in SA, we have quite a poor stratigraphic framework for this suite. Most of the plutons are simply mapped as undifferentiated Hiltaba Suite, which is not particularly informative a lot of the time. There are lots of informal names, which are not necessarily consistent between authors or between publications, so it can be quite difficult to find and link information together using search terms. Here I've put up just a few pictures from the Hiltaba Suite. There are lots of granites. They have some generalised features, such as being quite poor in mafic minerals, and mafic rocks are quite rare in the suite. But there's also a lot of variation in textures in chemistry, both within and between plutons. Without good map data and a stratigraphic framework, it can be quite difficult to answer questions like how these granites relate to each other and how they relate to mineralisation or mineralisation potential. So this suite is ripe for a value add by introducing a stratigraphic framework, which groups plutons with similar characteristics to help formulate questions and test theories. Stratigraphy is first and foremost based on lithology, with secondary consideration given to other information, things like geophysical signature, geochronology, geochemistry. This is a general stratigraphic description concept where observations that can be made simply in the field with your own eyes are the primary means of classifying rocks. So you don't have to go and get detailed geochemistry or high precision geochronology in order to know what you're looking at. Some of the general features documented in the review of the Hiltaba Suite, often several plutons from an area will have a similar range of textures and mineralogy. So these are two examples from the northern Eyre Peninsula. So each of these rock photos comes from a different pluton that's identifiable on geophysics, but you can see that those on the left and the right have quite different characteristics in terms of their texture, mineral proportions, things like that. And so they're grouped as two formation level units. Generally, plutons in the northwestern Gawler Craton tend to have more plagioclase than those in the central Gawler. These have been grouped as the Heartbreak and the Carina subsuites respectively, with several new formation level plutons in each of them. The eastern Gawler Craton, which includes the Burgoyne granite around the Olympic Dam region and the Tickerra granite on the York Peninsula, they tend to have quite a wide spread between K-feldspar and plagioclase-rich lithologies, which is partly due to magma mingling and also due to alteration. We've identified two different groups of plutons which have high-level intrusion characteristics. So north of the Uno Fault, which runs along the southern margin of the Gawler Range Volcanics, the high-level characteristics are myrolitic cavities and graphic textures. And these are a series of plutons which intrude in the light yellow along the margins of the Gawler Range Volcanics and within the Gawler Range Volcanics. And these have been grouped as the secret tank granite. In contrast, south of the Uno Fault, the rocks tend to have rounded phenocrysts within a fine-grained matrix as a lithology that's found co-magmatically with coarse-grained granite. So these are grouped into the Hiltaba Suite rather than the Gawler Range Volcanics because of that association with the coarse-grained granites, and they're grouped as the Pickerel granite. So this is a snapshot of the units of the Hiltaba Suite before and after this work. So you can see all of this grey are rocks that were previously classified as undifferentiated Hiltaba Suite. And after this work, there's a lot more that have been defined as named units. And we've essentially named every rock or pluton that we have samples for. So the other challenge with the stratigraphy previously was that all of those units that were named or defined were done so quite haphazardly at different stratigraphic levels, and so pulling it together into a much more rigid structure will help us start to answer some of the questions that we have. So if you can take this example and imagine how powerful our databases could be when we sort out the stratigraphy in other places in the state, this will be a powerful tool for mineral exploration. It provides us with a framework to explore important questions about the Hiltaba Suite, questions such as, are the different granite groups, are their magma sources important for mineralisation, or is the stratigraphy that they intrude equally as important or more important than the granites themselves? And are there age differences between these lithological groups that can help us pull out which ones might be important for different types of mineralisation around the state? This kind of work hasn't just been done with the Hiltaba Suite. We also updated the Archean and Paleoproterozoic stratigraphy in the northwestern Gawler Craton, which was released as a mesojournal last year. And we'll be providing updates on this work in the coming months as it's finalised. So if we round back to the South Australian Discover Mapping Project, the initial focus of data compilation will be in the northwestern Gawler Craton, both for the map and explanatory notes data, with the aim to extend the area of detail over time. This area has been chosen because it has good coverage with the recently acquired GCAS data, which gives us the potential to add a lot of value over previous geological interpretations because of the great detail in those data sets. There is potential for multiple different commodities in this area, so things like nickel, copper, PGEs, gold, critical minerals, all have shown some sniffs of potential in this area. There's generally fairly shallow cover, so less than 50 metres over much of the area, and we also have ongoing work by the GSSA in this area, so that includes the Gawler Phase 2 project, which means that we can immediately incorporate the new data from those projects into our new maps and descriptions. So this project will be at the core of what the GSSA will do and deliver going forward. I think that this is one of the most exciting projects that we're currently working on. Obviously, I'm biased because it's what I'm working on, but this will be the future of mapping and stratigraphy at the GSSA, and that mapping and stratigraphy is the basis of successful mineral exploration. We have enough unknowns in geology without covering old ground due to poor data accessibility. So with this project, we're aiming to set our stakeholders up for success by making the best data easily accessible and understandable. The project's throwing up plenty of geological and technical challenges, so we're looking forward to sharing updates with you as the project progresses. So watch this space.